So what I do with these equations before I do anything else is I solve for the battery voltage is. So if there's multiple batteries, I'll put all those batteries on the left side and everything else on the right side. So I could move this to the right side, but the way I like to write it is I put E1 on the left side and everything else on the right-hand side. So if I move this to this side, it becomes positive, everything else stays negative. So I have minus I1, and in fact, I like to move the minuses inside the parentheses, and I like to cluster my currents together. So I have minus I1 R1, so I'll put the minus with R1. And I have minus I1 R2, so I'll put the minus with R2. And then this minus times a minus makes I2 positive, so I'd have plus I2 R2. So I'm going to call that equation 1. So again, the process of what I'm doing is I'm putting all the EMFs on one side, and I'm putting everything else on the other, and I'm clustering them by currents. So I have everything multiplied by I1 and everything multiplied by I2 grouped together. So I'm going to do the same thing down here. And E2 is positive, so I'm just going to move everything else to the other side. So I have E2 equals, and now I1 is positive on this side, but when I move it to the other side, it would be negative. Oops, this is R2. And then I2s are negative here, so they'd be positive over there. I2, R2 plus R3. Okay, so let that sink in and let me know if you see an error or you don't know why I did what I did. Okay, nobody's hollering. Okay. Processing, okay.
Oh, because that's when you okay. Right.
Okay, so what we do when we do linear algebra, when you take a linear algebra class, this will become, this is what you do. If you have groups of equations, you want to solve them using the easiest possible method. You can plug those equations into matrices. So I'm going to take these two equations, and I'm going to write what they are equal to in matrix form. Okay? So in matrix form, I can write it like this. So you can get the equations right back out of these matrices. So matrix math says if I have two matrices multiplied together, this first term, top left-hand corner, is multiplied by the first term in this matrix. So look at that, I1 times minus R1 minus R2. And then we add this term multiplied by this term. So minus I2R2. And all of that is equal to what's on top over here, E1. And then In the bottom, I have minus R2 multiplied by the top term, I1. So we have minus I1 R2 up here. And then this term, R2 plus R3, is multiplied by I2. We see that right here in the equation. And all of that is equal to E2, which we see right there. So these three matrices is functionally equivalent to what we wrote in these two equations. This is like Candyland, but not as tasty. Mm-hmm. So linear algebra land, they like to put you through the paces and you never really know why until you take physics, and then you're like, oh, that's why we would do this. So what we're going to do is build a matrix A by taking the resistor matrix and the EMF matrix and concatenating them together. Okay, so that's the concatenation of those two matrices. And these are the values we are given. So when you actually plug in numbers, you'd have all of this filled in with numbers. So these are all of our knowns. And what we're looking for are the currents, I1 and I2. And so there's something in matrix, in linear algebra land, called reduced row echelon form. Which you'll find in your calculator under the matrix section called RREF. I call it RREF. And what reduced row echelon form is, it takes any matrix you give it, and it'll give you the identity matrix on one side, and the result you're looking for on the other. In this case, the result we're looking for is I1 and I2. So if I take my calculator and I enter in matrix A, and then I tell my calculator, I say reduced row echelon form of matrix A, it's going to spit out that big matrix. I don't care about this part. What I want is to grab the values it gave me for I1 and I2. And I wish I had my calculator emulator on here so I could show you guys on the overhead how to do this on a calculator emulator. My calculator is different. I've got a TI-86, so I'm not super clear on how to do this with the 89s. Most people have 89s. Is that right?
No, I have an 84.
This is something you can Google the instructions for. So
You just supposedly just put in there make.
so I don't know where in your calculator it is to go to matrix. Like I have a button, and
Matrix, blue matrix.
yeah, I have a one of my buttons is labeled matrix. I go there, I edit one of the matrices, I edit in all my values, I make it a 3x2.
Yeah.
Make a 3x2 matrix, and then I say you can actually type in the letters RREF and then parentheses and then whatever matrix name it is, or you can go through the functions and find RREF among your functions and just say function. Somebody who's taken a class before, like found out the key combination to easily enter in a matrix in the TI-89. So that when you're on the test, you can just say, I know all I have to do is type in da-da-da-da, put in my numbers, and it'll spit out.
I can't remember, but when you're putting in, I mean, this is all relative, I mean, because there's no numbers.
Right.
But there would be numbers representing the R1 and the R2, okay. I was just verifying. And then you just sort of threw in the app, what you would want. for the reduced row echelon form. I get that. I'm just saying.
Well, let's show.
Supposing or whatever. Just examples.
I'll show you on the overhead. Where's a problem? I did. Okay. So problem 2628. You guys have this solution handy.
Awesome.
So 2628 has 2 loops stacked on top of each other. It doesn't matter if they're stacked on top of each other. You can flip it sideways if that helps you do it. So I walk through, I do the top loop, I do the bottom loop, I plug it into my matrix right here. And so now I have values, 10, -5, -5, 15, and -5 and -5 over there. So then when
But you don't have I1 and I2.
well, that's what I solve, right? When I plug into my calculator, so my calculator, I'd plug in a 3x2.
So those are just representations of what you're going to put in there. Okay. I mean, I know what you put in, and then that's what you're getting.
Yeah, this is what it spat out.
Yes, I know.
-0.8 and -0.6. So this problem, we get 2 negatives on the current. So what does that tell us?
We went the wrong way.
Yeah, on both loops. So in red, I showed that the correct direction was actually this way. And then, of course, if they're coming in, then that means the correct direction down the middle has to be to the right. So I kind of like talk through fixing the current values and directions and stuff, because that's, I think, the only thing they want to know is the direction of the current down the middle loop. And you got to do the whole mesh analysis to figure it out. So.
Yeah, and don't mess up the negatives and positives.
Yeah, Jacob.
I think on the 83,
Uh-huh.
maybe not on the 89, I think on the 83 there's no RF, but you can build 2 matrices and do a matrix A inverse times the second matrix and figure it out that way. So you build like the first matrix of 2x2, and then you multiply the inverse of that times the E1 with the E2 matrix, and it'll spit out the same answer.
You do have
I believe.
I thought the 83,
Does 83 not do it?
I think the 83 does have RF. I have an 83 at home.
Okay.
I haven't had to do, I mean, I've done the matrix.
But I don't know the syntax on.
I'm a simpleton that doesn't understand linear algebra, and so
That's all right.
I don't know where to plug what. So what I do,
Okay.
I use the solver function within the calculator. The
So
solver
you
function-
put in these 2 equations
Yes, with
and
the
just
solver
tell it to
function
solve
and just
I1 and
solve it for
I2.
that, yeah.
Okay.
Yeah.
You're welcome to do it that way too. It works, you know,
My hardest part was
as you can see, like, you know,
I do.
all I'm saying is I solved with my calculator, right? I did the physics. I want to see that you guys can do the physics. And then whatever method it is, if you say solver method or matrix method, you know, I know you're going to do it with your calculator, because that's why we do mesh analysis, so we don't have to do the algebra method. So that's fine. I'll let you guys mess around with your calculators. I want everybody to get the chance to try
So you put square brackets.
either using Saban's method, using the solver method, or using the matrix math method I showed you to actually get the same answer I got. Okay, so let's take the time now to figure out how to do it. If you have any questions, then we can all figure it out together. Yeah, that's
Oh, I see him, okay.